Hello, my name is Steve Bowler, and in this video we're going to be taking a look at default routing. Specifically with default routing, we're going to be taking a look at how to set up default routing on Juniper routers. So in this example, just like if you have seen static routing, my Juniper static routing lab, we're going to be using the same exact network and the same topology, the same IP addresses, the same everything. So you're probably asking yourself, well, why are you doing this lab? Why didn't you just add it to the static routing lab? Well, the static routing lab was about 40 minutes, and I just wanted to break these up because I know that watching a hour-long or hour and 15-minute long video is very hard to do. So I've broken it up for you guys to make it easier to digest everything going on. And it kind of gives you a sense of accomplishment, right? If you get one video done, it feels good. So that's why, I broke this into two different video series. I have the default routing, and then I have a static routing. Anyway, enough about why I did that. And what I'm going to teach you is, in this lab, is how to set up default routing. Again, we're going to just get the basic configuration between R1 and R2 going, and then I'm going to show you and explain default routing and why you would use it and how to configure it. So let's get to R1. Let's go into R1 and let's go ahead and set up the basics. So the first thing we're going to do on R1 is we're going to set up the logical systems. We're going to do that by doing the command set logical systems R1. We're going to create the interface LT120. We're going to create the logical tunnel. The logical interface on this is going to be 12. It's going to be part of the family iNet with the address of, let's see if I can move this for you, with the address of 12.12.12.1. The next thing we want to do is create our peer unit. So again, our peer unit is going to be 21. I'm going to explain this 1 second. Let me just go ahead and get all of this configuration in, and I'll go ahead and explain exactly what these commands are doing. So I thought I would again use the same topology as the static routing lab, but I just wanted to break them up again because I don't like to have you guys sit through too long of videos, especially when I'm trying to teach different concepts and have them run into each other. It gets kind of confusing. So this video should be pretty quick, pretty short. Again, should be a lot shorter than the static routing lab. I'm going to just cover a little of the basics again, like I did with the static routing lab, but not as in much the detail. So if you're viewing this default routing lab, you might want to watch the static routing lab first, just to give you some basic pointers and help you out with the basics of static routing and how to create static routes on Juniper routers. So again, I'm just going to get through this configuration, kind of breeze through it pretty quickly, save us some time, and then I'll go back through and just explain it. Right now I'm just creating the connection between R1 and R2, the logical tunnel. Okay. Alright, looks like we have reachability. So again, what we did is I just created the connection between R1 and R2, the logical tunnel interface, the logical interfaces, the unit 12 on R1 and the unit 21 on R2. And what I did last there is I just did a simple ping from R1 to R2 inside the logical system configuration. And you can see from all of these responses we are successful. So let's go ahead now on R1. Let's just create the interfaces. The other interfaces on R1, again, if you weren't with me with the static routing lab, we have loopback 0 unit 0 on R1 and loopback 0 unit 1 on R2. Again, the difference between unit 0 and unit 1, when you're running logical systems, you can only have one instance of each unit on loopback 0. So that's why we had to create two different units for loopback 0. On R1, we're going to create, let's go into configuration mode first. We'll do set logical systems R1 interface loopback 0, again unit 0, and then we're going to have 1.1.1.1/24. I'm sorry, I forgot to put in the rest. Family inet address 1.1.1.1/24, and then also part of unit 0 we have the 11 network. Let's go ahead and create the ones on R2 as well. Again, that's unit 1 instead of unit 0. Family is going to be 2.2.2.2 for the inet family. Again, that's IPv4. So we have the 2 network, and we'll go ahead and put in the 22 network last. We went ahead and saved it, and now we should be able to do a run show route logical system R1. We see we have the directly connected interfaces that we just created, the 1 network and the 11 network off of loopback 0, 0. And then if I look at R2, we also have the interfaces, the 2 network and the 22 network off of loopback 0.1. So everything looks good so far. Again, like I said before, I was going to show you exactly how I created the logical tunnel connection between R1 and R2. If I do the command show logical systems, on R1 we have unit 12 under LT120. We have the 3 very important options. We have the encapsulation we have to set, so we set it to Ethernet on both sides. We have an IP address of 12.12.12.1. Then we have the peer unit 21. This is the binding between the logical tunnel units that is very key to having this connection between logical system R1 and logical system R2. So again, for R2 we had the encapsulation Ethernet, obviously the same encapsulation type. The IP address is on the same subnet, it's 12.12.12.2/24, and then we have the peer unit 12, which is telling the logical system to connect to R1. Again, R1's unit is 12, and that is our peer unit for logical system R2 under the logical tunnel interface for unit 21. And the last thing we did is we just created our loopbacks. We have loopback 0 unit 0 on R1 with the IPs of the 1.1.1.0/24 and the 11.11.11.0/24. On R2 we have loopback 0 unit 1, address 2.2.2.0/24 and address 22.22.22.0/24. So let's go ahead and take a look at our network diagram. We have all the IP addressing done, and we have the connections between R1 and R2 built. So what we're going to look at next is setting up default routing on the Juniper routers. So again, if you saw my static routing lab, you saw how we created static routes, and we're going to create default routes. What we're going to see is the default routes are very similar in command structure on how we actually create them. So you might ask yourself, well, why would you ever use a default route? Well, if you look at it in the perspective of, say R1 is a customer router, and R2 is a service provider router. And let's just say R1's only connection out is to the service provider. Well, could you run a routing protocol between these two? Obviously, yes, you could. Would it be the smartest thing to do? Probably not, because you don't really need dynamic routing to take place at this level. If you only have one way out of your network, then all you really need to use is what we call default routes, or default route in your router. And this default route, all it needs to know is how to get to the next hop, where it sends all of its traffic that's not in its routing table. So again, on R1, if we look on R1, if we do a show, let's just do a run. Again, this run statement, if I haven't explained it to you before, the run statement allows you in configuration mode, kind of like what the do statement does, when you're in a Cisco router or switch. If you're in global config or interface configuration mode, you can do show IP interface brief or whatever. On a Juniper, if you do the run and then show, it's kind of the same thing. So we can do a run show route logical system R1 to view the routing table for R1. And as you can see, it has several routes in the routing table. And what our default route is going to allow us to do is we're going to install this default route into our routing table, and say a destination IP address comes in that we do not know where to forward it. What our routing table is going to use is the default route. It's going to match on the default route, and it's going to send it to the next hop that we tell it to. So in this case, I'm going to show you this, how this actually is performed and is configured. On R1, we're going to set up a default route in the following way. Let's go ahead and actually get to R1's. We'll do set CLI logical system R1 to log into R1. We'll go into configuration mode, and we'll do the command set, again, routing options, static, and then if we do a space question mark, you see that we have the route statement. So again, this is very similar to setting up a static route. So we're going to do the command set routing options static route, and then it's going to ask us for the destination. So in this case, we want to match all traffic. That's the purpose of a default route. The default route says, well, if there is no match anywhere else in the routing table on the router, we're just going to use this default route to route all other traffic out to a specific next hop. So in this case, if we do the destination, is going to be to create a default route of 0.0.0.0/0. So what this is going to match on is everything. So if there's not a more specific route in our routing table, say for instance from R1's point of view, obviously these subnets are more specific, and routing 101 tells us, the basics of routing tells us, is that if there's not a more specific match, then the default route will be used, if there is one. So obviously these routes to the 11 network are more specific than the default route. So these routes are going to be preferred over the default route to get to that network. So we're going to do the command set routing options static route 0.0.0.0/0, and then we're going to assign it the next hop of, again, we're going to use R2 as the next hop. So we're going to set the next hop as being our connection to router 2, which is 12.12.12.2. And that should be it. So let's go ahead and commit that. we should be good to go on R1. Let's go ahead and test this. If we do a ping, if we go ahead and ping the two networks, so we'll ping, let's see, run ping 2.2.2.2. Let's do a rapid. Let's do a count 100 so you can see, our 1000 so you can see. As you can see, we are successful. So R1 is able to ping the 2 network. Let's see if router 1 can ping the 22 network as well. As you can see, router 2 can also ping the 22 network. And again, the reason why is if we do a run show route, oops, sorry about that. If we do a run show route, now we see that we have the default route added to our routing table from router 1's perspective. Again, the default route is coming up as a static with the route preference of 5. It has our next hop value of 12.12.12.2, and it specifies our next hop interface, or our local interface to reach the next hop, which is the logical tunnel 120 unit 12. So the default route is annotated by 0.0.0.0/0. So what's going to happen if you think we try to do a ping to the 22 network and source this from our 11 network? As we can see, the ping is not successful. If we go back and take a look at why this ping is not successful, if we look at our network diagram, we're doing a ping with the source of the 11 network with the destination of the 22 network. So these echo requests are sent to R2 with the source of these requests being the 11 network and the destination being a 22 network. Router 2 knows how to reach the 22 network because it's directly connected. So when router 2 tries to send the echo replies back to the source of these echo requests, which is the 11 network, router 2 looks this up in its routing table and it does not see a return path to the 11 network. So let's go ahead on R2 and let's go ahead and create a default route on R2 back towards R1. So if we were to look at the routing table on R2, we don't have a default route and we do not have a route pointing to the 11 network. So that is why our traffic is unreachable. Or the network is unreachable, I should say. If we go to R2, actually let's go ahead and do this. Let's go ahead and create a trace option. I'm going to show you this. I'm on a trace option high right now. I like trace options. They're pretty cool. So I'm going to show you a trace option. If you aren't familiar with the trace option, what they allow you to do is capture traffic and events and pretty much dump them to a file, and then you can view that file later on. So they're pretty cool. They're kind of the equivalent to doing debugs on Cisco iOS devices. Let's do a set logical systems R2 routing options, trace options, and we'll name our file default route. So within the routing options trace option, we're going to set the flag, again the file name, that's what our file name is, so we can do a show on that. We'll do a show log default route. I'll show you I'll show you when and how to do that. And the flag is going to show us what actions or what events we want to send to this file. So we'll do the flag. We're going to flag the route, trace routing information. So we're just going to flag all route statements, or all route activities. So you might already be understanding what I'm going to use this for. I'm going to go back to, if I do a set CLI logical systems R2, now I can do a show log, and you can see that we have the default route log. So let's look at that before I do this. We'll do a show log default route. See that I have a few entries in there, but not much. Let's do this on R2 again. Now let's set our default route. Let's create a default route pointing to R1. So we'll do the command set routing options static route, and then 0.0.0.0/0. Again, we're going to match all traffic. Then we're going to give it the next hop value of R1, which is 12.12.12.1. So we'll go ahead and commit and quit. And now from R2, actually let's do this before I go ahead and show you. If I do a show log default route, let's go ahead and point out some pretty cool stuff. With that trace option, what I was able to do is we're able to monitor this default route being added into our routing table. We can see that there's been a change made and an add. The default route, the 0.0.0.0 network, is now being added in with the gateway 12.12.12.1, which is router 1. This is a static default route with the route preference of 5. And this is the next hop interface, reachable interface, which is LT120 unit 21 on R2. So now if we go on R2 and do a show route, you can see that we have this default static routes in R2's routing table. Static route preference of 5, giving us our next hop, IP address, and the interface to reach the next hop IP. If we go back to R1, and now if we do a ping from R1, if we ping 22.22.22.22, we'll do a source of 11.11.11.11, rapid with the count of 1,000. And you can see that we have reachability. So before we had reachability, what we were seeing again is R1 was sending these ping requests with the source of the 11 network to the 22 network. Router 2 was getting these, and Router 2 did not have a default route in its routing table or a route to the 11 network, so Router 2 was dropping these packets. What we did to fix this issue, or what we showed you again in this lab, is default routing. We created a default route on R2 and pointed that back to R1. Once we did that, we were able to see that router 1's ping was now successful. We also added in a trace option feature on R2. We showed you within the trace option, we showed you this default route being added into our routing table on R2. So default routing is very useful in scenarios in which you only have one connection out to your service provider or out to the cloud or to the rest of the world. A lot of times routing protocols can be used, but for simplicity for your router, for the CPU and other resources, having a default route isn't a bad thing, and a lot of times you'll come across default routing. So what I wanted to do is just show you the basics of default routing on a Juniper router and get you familiar with it. So thanks for watching, and I hope you enjoy the video.